And now we actually need to input a third argument. Can you guess what that is? For those of you who followed the Python tutorial, well, you will guess what it's going to be. It's actually going to be n-tree, the number of trees in the forest. Well, of course, we're building a random forest, so it's actually a lot better if we can choose the number of trees that we build in our forest. And it's even better considering the fact that we're going to play around with different number of trees. That is, we're going to start with 10 trees, with a forest of 10 trees, and then, we'll try with a lot more than 10 trees, like 100 trees or 300 trees or 500 trees. So that's why we're going to input the third argument n-tree, and we're going to start with 10 trees. All right, so let's start with this, and that's all the arguments we need to build our random forest. We only need the independent variables, the dependent variable, and the number of trees. And that will already make a robust random forest regression model. And then we will make it even more robust by adding more trees in the forest. But before we continue, let's set the random factors to something fixed so that we all get the same results. So in Python we use the random state parameter equal to 0. Here we can do the same on R by using the set.seed function. And then in this function we actually input a seed, and we can use whatever seed we want. In Python we usually take 0 or 42, and in R what we like to do is to take either 1, 2, 3 or 1, 2, 3, 4. Let's use this seed to all get the same result, and that will make this tutorial easier to follow if you're coding at the same time. So now we're all good. We're actually all good with the whole code. We don't have anything to replace. The only thing that we'll do now is to try several random forests with several number of trees and look at the visualization results and look at the prediction to see if we're getting close to the supposed 160K per year salary of our new employee that is about to be hired. So let's do it. Let's execute the sections one by one. So let's import the dataset first. Here we go, dataset well imported. We make sure we have our two columns, the independent variable level and the dependent variable salary. Perfect. Now, no need to split the dataset into the training set and the test set. No need to apply feature scaling. And now time to create our first random forest. So let's do this. Let's execute this code section here. And here it is, random forest well created. Perfect. So now it's time to have fun. Would you like to visualize the result first or getting the prediction? Well, first, let's maybe visualize the results because we want to make sure we have the right model and we want to validate it. Because we will try several number of trees. Here we are starting with 10 trees, so we want to see if it looks like a correct model. So I'm going to execute this section. Here we go, and let's see what we'll get. Okay, so first of all, this looks fine. We don't seem to have any problem here. The only thing that we can improve very quickly is actually, those straight lines here that are supposed to be vertical. And to get a better representation of this, we just need to increase the resolution as we did for decision tree regression. So let's add 0.01, that will be sufficient. And let's re-execute this. And now much better. It almost looks like it's some vertical straight lines representing better the non-continuity. And so now what can we say? Let's zoom on this plot to have a better look. And now let's interpret. Okay, so the answer to the enigma that I asked you in the previous section and that I was asking you again in this tutorial is that we simply get more steps in the stairs. By having several decision trees instead of one decision tree, we have a lot more steps in the stairs than what we had with one decision tree. And therefore we have a lot more splits of the whole range of levels and therefore a lot more intervals of the different levels. So each straight horizontal line here separated by these vertical lines are one interval that is one split. And the fact that we get more steps in the stairs is actually quite intuitive because, if we get, for example, this prediction here for the 6.5 level, well, what happened for this prediction is that we had 10 trees voting on which step the salary of the 6.5 level position would be. And then the random forest took the average of all the different predictions of the salary of the 6.5 level made by all the different trees in the forest. And for example, if we take the fourth position level, 10 votes were made. Each of these 10 votes correspond to one prediction of the level 4 salary made by each one of those 10 trees. And then the random forest took the average of these 10 predictions, and this average is nothing else than the prediction of the level 4 salary made by the random forest itself. And so we get more steps because simply the whole range of levels is split into more intervals. And that is because the random forest is calculating many different averages of its decision trees predictions in each of these intervals. So that's what happened. It's quite intuitive. However, there is something important to point out here is that if we add a lot more trees in our random forest, well, it doesn't mean we'll get a lot more steps in the stairs. Because the more you add some trees, the more the average of the different predictions made by the trees is converging to the same average. You know, this is based on the same technique, entropy and information gain. So the more you add trees, the more the average of these votes will converge to the same ultimate average. And therefore it will converge to some certain shape of stairs here. So that's important to visualize this as well. And now, since we have our intuition of the visualization of the random forest regression in 1D, let's see what happens with the prediction.